All right, now we're going to solve some log equations. The first type we're going to be the simplest ones where it's just a log set equal to a number. Okay, we can use our little reverse spiral method and convert it to an exponential problem and then solve from there. So this one we've got 16 to the 3 halves equals x. All right, so you can either type this in the calculator, but if we don't have a calculator handy, remember the rational exponent is the bottom is the index of the square root, and the numerator is an exponent. So this is 16 times 16 times 16. All right, circling groups of 2 because it's a square root, and break that down to 4 times 4. So our answer to this one is 16 times 4. X equals 64. All right, same thing here. Do our little reverse spiral. So x cubed equals 1.331. All right, on this one, if we want to get rid of a cubed, we need to cube root. So x equals the cube root of 1.331. Okay, this one we probably want to use a calculator for. All right, so we second exponent, cube root, let's get it to type in there, cube root 1.331, and that's equal to 1.1. Okay, you may even remember that 1331 is 11 cubed. So the cube root of 1331 is 11, and then since we have the decimal in there, we put that in the middle, 1.1. All right, the calculator is super useful for those as well. All right, this one just says log of 10,000 equals x. Okay, so to solve this one without a calculator, you need to know what the base of this log is. So this is called a common log, and anytime there's no base written there, it's understood to be a base of 10. Common log, it has a base of 10. So this one's 10 to the x equals 10,000. All right, so 10 to the power of whatever the number is, that's how many zeros are behind it. So 10 to the power of 2 is 100, 2 zeros. This one has 4 zeros, so this has to be 10 to the power of 4, x equals 4. All right, you can always double check those in your calculator as well. 10 to the 4th power, there's your 10,000. All right, so let's try one with a little bit more algebra involved. All right, we're still going to use our backwards spiral method. So log base 6 to the negative 1 equals 2x minus 1. So 6 to the negative 1 equals 2x minus 1. All right, so 6 to the negative 1. Remember, with a negative exponent, you flip the number over. So that becomes a 1/6 to the first power, but we don't have to write that part, equals 2x minus 1. Okay, I'm going to add 1. All right, so 1 is 6 over 6. So 6 over 6 plus 1 over 6 is 7 over 6 equals 2x. And then we're going to divide by 2. Dividing by 2 is the same as multiplying by a half. It's a lot easier visually to see how this is going to work out when we do it this way. So that's going to be 7 over 12. All right, so on this one, we have an exponent here. You could leave it there and deal with it, but let's use one of our properties we learned about. So log properties tell us that if there's an exponent there, we can move it to the front and multiply the log by that number. So 4 times log base 5 of x equals 8. Well, now I know that I can just divide by 4 on both sides, and that's going to cancel that. Log base 5 of x equals 2. All right, and now when we do our little reverse spiral thing, it makes the problem much easier. I have 5 squared equals x. 5 squared is 25 equals x, and I've got my answer. All right, if we had done the reverse spiral at the beginning, I would have had 5 to the 8th equals x to the 4th. All right, which we could have solved probably with the help of our calculator, and we would have gotten the same answer, but the numbers are so much bigger. Look at 5 to the 8th. If we type that one into our calculator, huge number. All right, 390,625. So I like to avoid working with those huge numbers whenever possible. All right, these next few examples are going to use our properties more. All right, so you can never solve an equation with multiple logs. All right, well, unless they're on opposite sides of the equal sign. But if they're on the same side of the equal sign, you need to combine them together first and then solve for x from there. All right, so there's two things we got to do here. Anytime there's a number in front, you need to move that up, make it an exponent. So this is going to be 3 equals log base 8, not base, but log of 8 plus log of x cubed. Okay, then we combine them together using our addition property. This will be log of 8 times x cubed. Remember, when you're adding two logs with the same base, you can multiply the arguments of those logs together. All right, and now to get rid of the log, you need to raise it to the power of whatever the base is. So this is one of those logs that doesn't have a base. So that means it's a base of 10. So to get rid of this log, we need to raise both sides as a power of 10. So 10 to the log. And then over here, 10 to the third. Okay, that's the only way to get rid of a log. 10 to the power of. Remember, logs and exponentials are opposites of each other. So the 10 and the log base 10 cancel. That gives me 8x cubed. And then 10 to the third, that's 1 with 3 zeros behind it. That's 1,000. All right, let's keep going. Let's divide by 8. X cubed equals, all right, let's bring our calculator in here, help us out. 1,000 divided by 8. All right, leaves me with 125. And then to solve from here, we need to cube root. All right, 125 is one of the ones we should know off the top of our head. Cube root of 125 is 5. 5 to the third power equals 125. All right, so y'all give this one a try on your own. Pause the video and then come back and see if you got it right. All right, so we need to combine these two together. So it's going to be log base 12 of x times x plus 1 equals 1. All right, so I need to distribute inside here. So this is log base 12 of x squared plus x equals 1. All right, to get rid of the log now, I need to raise it as a power of 12. 12 because that's the same base. So this side needs to be raised to a power of 12. All right, this and the log will cancel, giving me x squared plus x. And then 12 to the first power is 12. Okay, so hopefully you recognize this. This is a quadratic equation left over, so it needs to be equal to 0. So I'm going to move the 12 over. X squared plus x minus 12 equals 0. All right, usually we can factor these at this point, and this one's no different. X plus 4, x minus 3. And that gives me two possible solutions of x equals negative 4 and positive 3. Now, we always have to check for extraneous solutions. Should be used to that by now. We've done this a lot. The extraneous solutions, anything that makes a log be 0 or a negative number has to be thrown out. You can only take the log of positive numbers. So negative 4, if I plug that in right here, that's going to be taking the log base 12 of negative 4. You can't do that. All right, even if I plugged it in here, that'd be log base 12 of negative 3. You can't do that. Negative 4 has to be thrown out. Okay, you can try it in your calculator even. If we do second control log base 12 of negative 4, see, error. It's a non-real number. Okay, and we're not going to deal with any imaginary numbers with logs in this class. Okay, so you just throw 4 out. 3 works just fine. Log base 12 of 3 is good. Log base 12 of 4, good. So x equals 3 only is our answer on this problem. All right, let's try a couple of these with a minus sign in there. Okay, so remember our property for the ones with the minus sign is you divide the arguments. So this is going to be log base 4 of 100 divided by x plus 1 equals 1. All right, now that we've combined them, we are allowed to get rid of the log. Okay, notice how I'm not allowed to just go through at the beginning and do 4 and 4 and 4 like that. You can't do that. Okay, I see that mistake happen all the time when people are first learning how to solve these problems. Okay, so don't let that be you. Make sure that you combine the two logs together first and then go through and raise both sides to a power. All right, and this side gets raised to 4 to the power. So these cancel. 100 over x plus 1 equals 4 to the 1, which is 4. Okay, I've got a fraction, so probably want to multiply by the denominator to get rid of that. All right, so we'll cancel out the x plus 1s. We'll get 100 equals, distribute the 4 over here, 4x plus 4. All right, I'm going to subtract 4, get me 96 equals 4x. And then I'm going to divide by 4, and 96 divided by 4 is 24. All right, last one here. Give it a shot on your own. Come back, see if you got it right. All right, so this is a log with a number in front. So first thing we need to do is move that up as an exponent. You can't combine the logs with numbers in front like that. All right, now we can combine these together. Log of x squared over 4. All right, so this is a common log, no base, so we know that means it's a 10. So I do 10 to the power of log and do 10 to the power of this. All right, so those cancel, x squared over 4. All right, this one's a little tricky over here, 10 to the 0. It's not 0. Remember, anything raised to the 0 power is 1. Okay, be careful of that. All right, multiply both sides by 4. Get rid of the fraction. So that's x squared equals 4. And then square root. Okay, remember we're supposed to put a plus or minus in front of our square roots when we solve equations like this. So I get plus or minus 2 as my answer. Okay, but remember, no negatives are allowed to be inside the log. So if you plug in negative 2 right here, that'll make that log a negative. Can't have that. So the negative portion has to actually get thrown out. So our only real answer to this problem is positive 2. X equals 2.